Okay, I think I'm recording right now. Yes, perfect. All right. So yeah, yesterday I introduced the notion of function, right? We discussed a little bit the definition of function, and then we discussed like two ways to describe functions, right? We said we can use either equations or graphs to to describe functions. So let me just remind you. So we said there are two ways, two important ways to describe functions. Okay, so first I'm gonna just zoom out, I guess, here. Okay, so functions. So first way we said we can use equations. Use equations, right, to express or describe functions, right? So this is like the first problem in the homework. So problem one in the homework, right? And then we said we can use graphs, right? And then yeah, so we started a discussion about graphs. So first I tried to explain what's a graph, right? First, so what's a graph? Okay, and we said the graph is just a, you can think of a graph like just a twisted line. Okay, it's just a twisted line. Okay, two. So we discussed how we determine whether a graph represents a function or not, right? So does the graph represent a function? And so we said we need to use the vertical line test, right? Vertical lines test, right? So to check if the graph represents a function or not. And then the third point was about how do we read graphs, right? Okay. How do we read graphs? And so the idea was, if I give you my input X, you need to find like the corresponding output Y, right? So given X, given the input X, we need to find the corresponding output Y. So this is, I think, this is part of the problem 2 and 3 in the homework, corresponding Y. In the homework. Anyway, so we are done with this. Now, last question we didn't answer yesterday was how do we graph functions, right? So last question. So question number 4. So how do we graph functions? Okay. So the idea is, well, later, I think in chapter 2 and 3, we'll see how, and even chapter 4, we'll see how to graph some special functions like, logarithmic functions, exponential functions, trig functions. And in chapter 2, we'll see how to graph like polynomials, rational functions, etc. Right? But for the moment, so what we can do to graph functions is just to plot as many points as you can, and then just connect the points. So the idea is to plot as many points as you can. Okay, and then connect the points. So we have to join the points. So let me give you an example, simple, very simple example. Right? So let's say I'm gonna graph the following function. So f of x equal to minus 2x plus 1. Okay. So again, guys, you think of x is the input, right? X is always the input. Now, so I want to graph this function. As I said, the idea was to plot as many points as we can. So I'm gonna make like a table with values of x and y. Okay, so let's make a table here with values of x and output y. So the output y is given by f of x, right? So you think of this f of x. This is your output y. Okay, so this is your output y. Okay, so y, the output y is supposed to be equal to f of x. So for example, let's just take I'm gonna just take some random values. Let's say I'm gonna just take 4 or 5 values of x, right? And then I'm gonna evaluate my function f. So for example, let's just take a very simple values of x. For example, x equal to 0. So if my input x is 0, so what will be my output y? So y, the output y, which is f of 0. So this is the output corresponding to the input 0. This is equal to, so all you have to do, guys, of course, is to substitute x. You see, this is your function. Here's my x. And all I have to do is to substitute this x by 0. Okay, so it's going to be just, negative 2 times x. So that will be negative 2 times 0, right? And then plus 1. Okay. So the answer here would be, of course, that's rule multiplication first. So that's the 0 plus 1. So the answer would be positive 1. Okay. So what I'm saying is, if my input x is 0, my output y is 1, right? So here I'm gonna plot the first point. So let's graph here f of x. So graph of f of x. So to graph of f of x, of course, I'm gonna need the 2 axes, the x-axis and the y-axis. All right. So I'm gonna just take some values here. Let's say 0, 1. So this is supposed to be 0, 2, negative 1. Let's say negative 2, etc. Here's negative 1. So what I'm saying here, so I'm gonna plot the first point. So what's my first point? First point is, so what I'm saying is that when x is 0, right, my output y is 1. So my x is 0. Here's x equal to 0, right? This is x equal to 0. And what I'm saying is, so if my input x is 0, then the output y is 1. So I'm gonna just, you can just draw this like a vertical line, and you have to go to output y equal to 1. So here's my first point. So here's where y is equal to 1. Okay. Does this make sense to you guys? So this is like this is my first point. This is the point where the input x is 0 and the output y is 1. Yeah, that's the point 0, 1. Absolutely, Lord. I'm gonna explain the notation, points notation later. So that's my first point. Now let's just take another point. or another value of x. And again, I'm just taking random values of x. Okay, there's no special values. Or so let's say x is 1, right? So I'm going to compute my output y, which is f of 1. And again, all I have to do is to substitute x by 1. So it's -2 times 1 plus 1, which is, so it's a -2 times 1. That's negative times positive. So it's going to be -2 plus 1. So the answer is -1. Yeah, thank you, Lorden. So this is -1. So what I am saying is now, if my input x is 1, then my output y is -1. So where x, let's see where x is 1. So my input x is 1. So here's x equal to 1, right? Now the corresponding output, it's -1. So what I have to do again is I have to draw this vertical line, okay? And I have to go to the level where y is -1. So of course it's -1. So I'm gonna go down, right? And when you arrive at the level of -1, then you're gonna stop, and that will be your point. So here's my second point. Okay. So again, x is 1. So you start from 1 because x is 1. And then the output is -1. So what you have to do is draw your vertical line, and you have to go to the level where y is -1. Okay. Let's take another point. Let's say x is -1. All right. So then y, which is f of -1, is equal to, so it's -2 times. So be careful, guys. This is a negative number. So as I said yesterday, my advice is to use parentheses whenever you have a negative number. So this is -2 times -1 with the parentheses. Okay, and then plus 1. So the answer would be, yeah, Lord, absolutely. So -2 times -1, so negative times negative, that's +2, and plus 1, that will be +3. So let me just plot phi here. I'm gonna need phi. So what I'm saying here now is that if x is -1, so here's x -1, right? The output y is +3. So I have to draw my vertical line, and I have to go to the level where y, or to the height where y is +3. So I'm gonna go up here because y is positive, and I arrive to the level where y is +phi. And so this would be my third point. Okay. So is there any question how I plot these points, guys? All right. Okay. So I don't think we need really to plot more points. So all I have to do now is just to connect these 3 points, right? So I'm gonna connect these 3 points. Let's see, this here. All right, and that will be the graph. I mean, it's not perfect, of course, but that will be the graph of f of x. So this is the graph of f of x. Okay, I just connected my points here. So I mean, that's like the very general idea. So that's how we graph functions in general. All right. Okay, so let me give you an exercise, guys. So I'm going to give you, let's say, 1 or 2 functions, and you have to try to graph. It's an exercise here. So please try to graph the following functions. Following functions. Well, try to just plot probably 3 points. Okay, 3 points, that's enough. Let's say plot. I mean, what's really important for us here is to know how to plot the points, So first function, let's say, let's take f of x equal to, let's take absolute value of x plus 1. The plus 1 is outside the absolute value. Okay. And number 2, let's say f of x is x squared plus 1. Okay. All right, so I'm going to give you, let's say, 5 minutes, guys, to try to grab these functions. Again, just pick 3 points. You don't have to pick more than 3. Okay. I mean, the point here is just to know how to, plot points in the graph. Just to remind you guys, the absolute value of any number is just, it's always positive or 0. So absolute value of 0 is just 0. But so if you have the absolute value of positive number, then the answer would be the same number. And if you have the absolute value of a negative number, then you have to take the opposite. Okay, just to remind you here, like, sorry. So what I'm saying is, so here's the remark. So if you take absolute value of positive 5, that would be positive 5. So if you take absolute value of negative 4, so if you have a negative number, then you have to take the opposite. So that's positive 4. And of course, if it's just 0, the absolute value of 0 is just 0. Okay. Yeah, that's correct, Rabiul. Yeah, very good. Norden, let's see. Yes, correct, Norden. Joel. So -1. Yes, yes, very good, Joel. Yes, correct, Joel. Yes, review. That's right. So it's really important, guys, that you know how to plot the points, okay? If you have the trouble plotting the points, let me know. Please let me know, all right? So, because, you know, next chapters, we're gonna do a lot of graphing, okay? So it's really important that you know how to plot the points. Sing, number one. Yes, absolutely, Xing. Yeah, right, correct. Yeah, Lorden, that's right. Yes, correct, guys. Yes. Yeah. All right. Does anyone need more time? Probably not. Okay, so let me go over the first. Okay, perfect, Mia. Thank you. So let me go over the first function, f of x equal to absolute value of x plus 1. So as I said, just take a couple of values of x. So here's my input x, and here's my output y, which is by definition is equal to f of x. So for example, if you just take x equal to 0, then the output y, which is f of 0, that will be absolute value of 0 plus 1. As I said earlier, absolute value of 0 is just 0. So that will be 0 plus 1, and that will be positive 1. Okay, so what I'm saying is that if my input x is 0, then my output y is positive 1, right? Let's take another value of x. Let's take, for example, x positive 1. So then y, the output y would be f of 1, which is absolute value of positive 1 plus 1. And as I said, if you have a positive number, then the absolute value of a positive number would be just the same number. So that's 1 plus 1, and that will be 2. Okay, so if my input x is positive 1, then my output y is positive 2. And finally, let's just take, for example, x equal to negative 1. All right. And then, so my output y, which is f of negative 1, there'll be absolute value of negative 1 plus positive 1. And so absolute value of negative number, that will be the opposite, right? So that will be positive 1 plus 1, and that will be positive 2 again. All right, so here I have like 3 points that I can plot. So let's plot these 3 points. So here's my x-axis, my y-axis. So I'm gonna probably need 0, positive 1, negative 1 here. And then on the y-axis, this is my y-axis, I'm gonna need positive and a positive 1 and positive 2. Anyway, so first point, let's see. So what I'm saying is that if my x is 0, then my y is positive 1. So if my x is 0, here's my x is 0. The output y is positive 1. So I'm going to draw my vertical line, and I'm going to go to the level where y is positive 1. So here's where y is positive 1, and that will be my first point. Next point, x is positive 1. The output y is positive 2. So here's my x positive 1, and I'm saying the output y is positive 2. So I have to go up to the level where y is positive 2, right? And so that this would be my second point. And finally, last point, when x is -1. So let me probably pick a different color. Let's pick a yellow here. So if x is -1, then my y would be positive 2. So you start from x is equal to -1, you draw your vertical line, and you go to the level where y is positive 2. So here's where y is positive 2. So then my third point would be this one here. Okay. Now I have to connect these 3 points. So you have to go from left to right, guys. Okay, it's better to go from left to right. So I'm gonna go like from this point here, this one, right? And so my next point would be this one here, and then my third point, this one here. Okay, and so this would be like the graph of f of x. Okay. Is there any question, guys, about this graph? All right, no. Okay, perfect. So then I guess number 2 is kind of similar to the problem number 2 is similar to this one. So probably I won't, I guess I won't solve number 2. So yeah, so I guess we can move to the next next thing, which is, yeah, the domain and the range. So you're gonna need the domain and range in the homework 1. So we need to cover this today. Okay, so next. So we're gonna discuss domain and range of a function. Right. So first, we're gonna start with domain, of course. Let's start with the domain. So first, with the domain. So what's the domain of a function f? So by definition, the domain of a function is the set of all x values that you can input. Okay, so the domain, let me write down the definition. So the domain of function f is the set of all. So here it's of all x values. So the domain, it's about the inputs, the set of inputs, right? So x values that you can input okay, you can input. So the next question is, how can we find the domain of a function, right? So how do we find the domain of a function f of x? So remember, guys, we said we can describe functions using either equations, right, or graphs, right? So I'm going to show you how to find the domain of a function f using graphs or equations. Okay. So first, I'm going to show you how to find the domain of a function using equations. So first, one here. So using equations. All right. So, well, I'm gonna use first, like, I'm gonna give you first like an example. I'm gonna show you how to find the domain of a function. But before the example, there are 2 rules that you need to know, guys. There are 2 main, very important rules that you need to know. Okay, so the rules are the following. So there are 2 rules, 2 very important rules. Okay, so the first rule is, we cannot have negative numbers under a square root, right? So first rule, so rule number one, as you know, I mean, we cannot have, negative numbers under a square root, under a square root. Actually, not just a square root, but or a square root or any even root, or any even root. So what do I mean by even root? Like fourth root or eighth root or sixth root, etc., etc. So whenever I have like even root, then you cannot have a negative number under that root, right? So that's the first rule. The second rule is that, as you know, we cannot divide by zero, right? So rule number two. Okay, so we cannot divide by zero, as you know. Cannot divide by zero. So we're gonna use these two rules to find actually the domain of a function f. So we're gonna use so this the rule number one and two to find domain of a function. So to find the domain of f of x, find the domain of f of x. All right. So first example. So example one. Example one. Let's say my f of x, y, which is f of x, is equal to x minus 1 over x minus 2. All right. So here's my function f. It's x minus 1 over x minus 2. So the question is, so we need to find the domain, right? The question is to find the domain. So what does it mean to find the domain, actually? Find the domain, right? So it means that, so the question is, what values of x we can input here, okay? So when you find the domain, so the question is actually, what values of x we can input here, okay? So that's what I mean by finding the domain of this function f. What values of x we can input here. All right, so I have this function f, it's x minus 1 over x minus 2, right? Now, I have, as I said, we have these two rules, right? We said there are two things we need to know, right? We cannot have negative numbers under the square root, and we cannot divide by 0. So when you see such a function f, x minus 1 over x minus 2, and you need to find the domain, there are two things you need to do, guys. First, you have to check if there is any square root in the function f. Well, like here in this example, there is no square root, right? So if there is no square root, then there is no problem with the first rule. The first rule says that we cannot have negative numbers under the square root, but there is no square root anyway, okay? So we can just forget about the first rule because there is no square root, right? So, so we can forget. So rule number one. So rule number one is okay because there is no square root. So we don't have to worry about the square roots, right? So there is no square root. The thing is, if you had a square root, then you have to make sure that wherever you have under the square root is not negative, right? Because we are not allowed to have negative numbers under the square root. Now, what about the rule number two? So the rule number two says that we cannot we cannot divide by 0, right? And the question here is there a division in the function f? Well, I mean, obviously function f is a quotient, right? It's the x minus 1 divided by x minus 2. So there's a division here, right? We are dividing by x minus 2. So if you have a division, right, then we have to make sure that we don't divide by 0, right? So here, so in the function f, so in f of x, there is a division. Right, we are dividing by, yes, Rabiul, yes, absolutely, you're right. That's the idea. So there is a division. So and we said we cannot divide by 0. So we have to make sure. So we have to make sure that we don't divide by 0. Okay, we don't divide by 0. So now the question is, what's the denominator here? So we are dividing by what? We are dividing by not just x. We are dividing by, so the denominator here is x minus 2, right? So I'm dividing by x minus 2. So I have to make sure that x minus 2 is not 0. Right? So we have to make sure that x minus 2 is not 0. Not just x, but it's x minus 2 because we are dividing by the whole denominator, not just x. We are dividing by x minus 2. So it's not 0. Right? Now, the question is, for which input x, the x minus 2 is going to be 0, right? Because again, we need to avoid division by 0. So I have to make sure that my input x, so the value of x minus 2 is not 0. Okay, so the question is, so we have to solve x minus 2 equal to 0. Right? So the question is, when x minus 2 is 0, well, x minus 2 is 0. You can just, here I'm going to add positive to both sides, right? So then my x would be positive 2, right? So what I am saying, guys, here is that when my input x is positive 2, right? If you substitute x here, you see here this x here in the denominator. If you substitute x by positive 2, if my input x is positive 2, then in the denominator, I'm going to have 2 minus 2, which is 0. And I'm not allowed to divide by 0, right? So the idea is I have to exclude the value x equal to 2, because if my input x is 2, then I'm going to have 0. I'm going to be in trouble, right? So remember, the domain was the set of all x values that you can input, right? But here we cannot really input x equal to 2, because if my x is positive 2, then the whole denominator is going to be 0, and that's not okay. Okay. So what I'm saying here, so what we are saying here is that, so if x is 2, then the denominator is 0. And so, so the conclusion is that, so we have to exclude x equal to 2. So my input x, my variable x, it can be any real number, okay, except 2, because when x is 2, we're going to be in trouble. Denominator is going to be 0, and we are not allowed to divide by 0, right? X can be 100, can be 99, can be 1/2. It doesn't matter, right? The only problem is when x is positive 2, because then the denominator is going to be 0. Okay, so my x can be any real number except positive 2. and that will be my domain. So the domain, again, is the set of all x values that you can input. So here I can input anything, any number, except the +2. Okay, so your answer should be, so the answer to the question here, the answer, so the domain, so the domain of f of x, which is x minus 1 over x minus 2, is any real number except the +2. Okay. So my x can be any number. I don't really, it doesn't matter, except when x is 2, then the denominator is 0. So that's why we have to exclude x equal to 2 from the domain. Okay. So actually, this is not the final answer because in the final answer, guys, we need to use what I call the interval notation. So for the final answer, so for the final answer, and I'm going to explain what I mean by the interval notation. So, oops. So for the final answer, so we need to use the interval notation. So in the homework, guys, or in the test, or in the final, for sure, you're going to have probably problems about the domain and the range, okay? I guess in the first test. So the second question is going to be about the domain and range of functions, okay? So your answer, your final answer should be in the interval notation. So I'm going to explain now, of course, what I mean by the interval notation. So what's the interval notation? Okay, so now, well, so in this example, so what I am saying is, I have my number line, okay? It goes from -infinity to +infinity, right? I have like 0, 1, 2, etc., wherever, -3, wherever. Okay, so I have my number line. And so what I'm saying here is that my domain, yes, Rabiul, you have the right answer. That's correct. So what I'm saying here is that my domain can be, or my x, it can be any real number except the +2. So my domain is like on this number line, it could be any number. So it could be anything. It could be a decimal. It could be, of course, a fraction. Doesn't matter. But except the +2, right? So I won't include the +2 in the answer, right? And so to exclude the +2, we're going to use parentheses. So here, I'm going to use parentheses to exclude this +2, okay? So the parentheses are used to exclude, so here, so it means that, parentheses, so we use parentheses to exclude the +2. All right, so what's the final answer then? Well, so then final answer would be final answer, and this should be your answer in the test or in the final. Final answer, so domain of f of x, which is, we said it's x minus 1, right, over x minus 2 is, so you see here, I have this number line. It goes from -infinity to +infinity. So you always start from the left, guys. So this is really important. So you go always from left to right, always. Okay, so you go always from left to right. So if you go from the left, so you start at negative infinity, right? Go from left to right. So we're gonna go this way, right? From left to right. So you start at negative infinity. So here's my negative infinity, right? And then, so I have my whole domain here, right? And then I have to stop at positive 2 because I need to exclude positive 2, right? So I'm gonna go from negative infinity to positive 2, but I'm gonna stop at positive 2 because I have to exclude the positive 2. And to exclude the positive 2, I'm gonna use parentheses, right? This is my parentheses here to exclude the positive 2, right? And then, of course, I have to continue, right? After positive 2, I have this whole thing here, this part here, right? So it goes from, well, it goes from, again, from positive 2 to positive infinity. So here's my positive 2 to positive infinity. Okay, and again, I have to exclude this positive 2. Okay, now for infinity, guys, either negative or positive infinity, they are always excluded because positive or negative infinity, they are not numbers. Okay, so we have always to exclude the negative and positive infinity. So here's my parentheses here for negative and positive infinity. Okay, so here negative positive infinity are always excluded. Okay, it doesn't matter. They're always excluded because they are not numbers. They are not finite numbers. So I have like two intervals here, right, guys, right? I have like the union of two intervals. I have like, this is my first interval. It stopped at positive 2, and then you start again at positive 2, but positive 2 excluded. It doesn't start at 2.1. It doesn't start at 3. It doesn't start at 2.5. It really starts again at positive 2, but you have to exclude just the positive 2. You don't like to exclude. So if you start from 3, if you say this is 3 to positive infinity, that's not true. So for example, what about 2.5? Well, it's still in the domain 2.5. There's no problem with 2.5. So we really need to start from 2 again here. Okay, not from 3, not from 2.5 or 2.1. We really need to start at, again at 2, right? So we have like, so as I said, we have like the union of two intervals, this one here and this one here. Okay, so the symbol for union, so it's like a capital U. Okay, so this capital U means the union of two intervals. So this is this symbol here means a union. Okay, because I have like two separate intervals, right? I have this first interval going from negative infinity to positive 2, and I have to exclude this positive 2, and then I start again at positive 2, excluded again, and to positive infinity. Okay. So this should be like your final answer to this question. Don't we're gonna do, of course, more examples, right? It's just this is just like the first one. So don't be scared, guys. If you don't you feel like kind of confused, it's normal because it's like just a first example. Let's do more examples, all right? Unless there's a question about this specific example. So you see, this is what I call the interval notation, right? You use this parentheses. And then, all right, so let me do another example. So this is first example. So that's the domain. Example number 2. So the example number 2. Well, example number 2, I'm gonna just take, for example, y, which is f of x, equal to x squared plus 1. Okay, and again, the question is to find the domain of f of x. Right. So as I said, we have two things to check, right? Two things to check, guys. Whenever you want to find domain of a function, two things to check. This is like the rule. The first thing to check is, do we have division? Because we need to avoid division by 0. And the second rule is we cannot have negative numbers under the square root. So the question is, so there are two questions you need to ask yourself whenever you want to find the domain of f of x. So is there a division? Well, the answer is no, of course. Obviously, there's no division. Yes, Rabiul, absolutely. Negative infinity, positive infinity, yes. And the second question is there a square root? And the answer is no. Obviously, there's no square root here. There's a square. It's not the same thing as a square root, right? The square root or even root? Well, the answer is no. Okay, so there's no problem here. So my input x, it can be any real number. Okay, so my input x, so the input x, so the input x, it can be I didn't know that. I didn't know that actually, Rabiul. Can be any real number. And so the final answer, so your answer should be, so you don't have to draw this number line, guys. I'm just trying to explain, I'm using this number line to explain why, to explain the answer, right? So I have my number line, etc., 0, 1, wherever. And so what I'm saying is that, my input x, it can be any number, so I don't have to exclude anything, right? So it's the whole number line. So the final answer, so the domain, again, this is just to explain my answer, right? So in your test or in your homework, of course it can help, but what you need to write down in the answer is the following. So the domain of f of x is just, it goes from negative infinity to positive infinity. And as I said, infinity, either negative or positive, they are always excluded. So I'm going to use parentheses. Okay. Actually, there's another notation for this interval, negative infinity, positive infinity. So just for your information, guys, you can just say this negative infinity, positive infinity, that's what we call the real number line. So that's R. That's what we call R. Okay, this was like a kind of simple example, but just to show you guys that sometimes, of course, there will be no division or square root, so you don't have to worry about anything, right? And then, so your input x can be any number, and so the domain is just the whole number line. Okay, now a third example, we're gonna have a square root. So example number 3. Example number 3. Now, let's say f of x is square root of, let's say, x plus t minus 2. Okay. And of course, the question is to find the domain of f of x. Again, guys, please feel free to ask questions, all right? Don't be shy. You can interrupt me anytime and ask me any question, all right? So find the domain of f of x. All right, so as I said, first question you have to ask yourself, is there division? Is there a division? Obviously, there's no division, right? There's no quotient, right? Is there a division? No. Okay, now the second question is, their square root? And well, the answer is yes, of course. And so if it's a yes, then we have to be careful, right? So remember, when you have a square root, you have to make sure that wherever you have under the square root is not negative, right? You cannot have negative numbers under the square root. So the question is, so what do we have under the square root? Well, under the square root, so here's my square root. So the -2, it's not under the square root, right? So it's not inside the square root. The -2, I don't really care about it. It's outside the square root, so it doesn't really matter, okay, the -2. Now, what we have exactly under the square root is the x plus 3. Okay. So again, what's the rule? You have to make sure that this x plus 3 is not negative. So you have to make sure that this x plus 3 must be positive or 0. Okay, so x plus 3 must be positive or 0. So it's fine if you have a 0 under the square root. I mean, square root of 0 is just 0, right? Because 0 times 0 is 0. So square root of 0, it's fine. Square root of 1, square root of a positive number, it's fine. But the square root of negative number, that's a problem, okay? I mean, square root of a negative number actually do not exist, unless, of course, you include the complex numbers, but that's another story. So, but anyway, so in our course, so whenever we have, we cannot have negative numbers under the square root. So this x plus 3, as I said, it must be positive or 0, not just 0, positive or 0. So how do we translate this? X plus 3 must be positive or 0. So x plus 3 must be positive or 0. In other words, it must be larger or equal to 0. Okay, so x plus 3 is larger or equal to 0, right? So if it's larger than 0, it means that's positive, right? Now, how do we express the fact that x plus 3 is larger or equal to 0? So we're going to use inequalities, right? So larger or equal, that will be this symbol here. This is larger or equal to 0. Okay, so as you can see, this line here means or equal, and this symbol here means larger. Okay, so just to remind you guys, so just remark here, just to remind you the symbols. So if you have like this symbol here, this is strictly larger. The other way, that will be less. So if you have like with the line here, that will be larger or equal. And then if you have the other way around, so that will be less or equal. Okay. Anyway, so we need this x plus 3 to be positive or 0. So it's larger than 0 or equal to 0. Okay, so that's why I have this inequality. Now we have to solve this inequality, right? So we have to solve for x now. You don't hear it? Do you hear me, guys? I think Lorden has a trouble with the
Yes,
sound.
Professor. I can hear you.
You can hear me, guys? Okay.
Yes.
Okay, probably Lorden, you have to fix something. I'm not sure. But it's not well. Anyway, so we have to solve for x now, right? Because we are interested in x. We need to know what will be the domain, right? So we need to find the set of the inputs x. So we need to solve for x. So solve let's solve for x, sorry. So solve for x, right? So how do we solve for x? Well, on the left side, I have this x plus 3, so I need to get rid of this plus 3. So all you need to do is just to subtract. This is plus, so the opposite operation would be minus. So I'm gonna subtract 3, and we have to do the same on the other side, right? So here, we're gonna subtract 3. So then the 3 cancel out here. This is on this side. So my x is larger or equal to, so 0 minus 3, that will be negative 3, right? So 0 minus 3, that's negative 3, okay? And so I got my x. So what we are saying is that my x is larger or equal to negative 3, okay? So that's what this inequality says, right? So x is larger or equal to negative 3. Okay, so my input x, it must be larger or equal to negative 3. So now I can answer, the question. So the domain, so the final answer. So the final answer. So I'm gonna use again my number line just to clarify things here. So this is my negative infinity. Here's my positive infinity. You can put 0 if you want, etc. I'm gonna need the negative 3. It's very important here. I'm gonna need this negative 3 here, right? So what I'm saying is my domain, my x, my input x is larger or equal. So it can be equal to negative 3. So this is really important, guys. So larger than 3, larger than negative 3. So it means that x is on the right side of negative 3, right? It's larger than negative 3. So it's on the right side of negative 3. Okay. And so this is larger or equal. So I need to include the negative 3, right? So negative 3 here is included because my input x, it can be equal to negative 3, right? Or equal. So it can be equal to negative 3. So I'm gonna need I need to include the negative 3. Remember, guys, we use parentheses to exclude, right? Now, to include a number, we're gonna use the brackets. So I'm gonna use a bracket here to include this negative 3. So the bracket means we include the number. So bracket, the bracket means that negative 3 is included in the answer. Okay. So the domain of f of x is, so it goes from negative 3 to, again, guys, you go from left to right. This is really important. You go from left to right, right? So it goes from negative 3 to positive infinity, okay? Positive infinity, as usual, it's excluded, right? But then negative 3 must be included. So I'm gonna use a bracket for negative 3. Okay, and that will be the final answer. Again, guys, as I said, you go from left to right. So if you write like positive 3 to negative, positive infinity to negative 3, that's not actually correct. You need to go from left to right. So it's like from the smaller number to the largest number. So it's like from negative 3 to positive infinity. So this is not correct. Okay, from left to right. So it's from negative infinity to positive infinity. So, and that will be the domain. So what I'm saying, guys, is that my x, my input x, it can be any number larger or equal to negative 3. Let's see if this makes sense, right? So let me just come back to my function f. So my function f was like this square root of x plus 3 minus 2. So let's pick a number. So I'm saying my domain is any number larger than negative 3. So if it's okay to pick any number, any input x larger than negative 3. So for example, I don't know. So let's say x is 1. Okay, x1 is larger than negative 3. So let's say if it makes sense. So if x is 1, then under the square root, I'm gonna have like 1 plus 3, and that would be 4. That would be a positive number, right? And square root of positive 4, that would be a positive 2. So then the answer, final answer would be like 2 minus 2, that would be 0. So yeah, so my input x could be equal, my input x can be equal to 1, right? And that's a number which is larger than negative 3. Now, if you pick, you can see now, if you pick a number which is less than negative 3, which is not in the domain. So for example, if you pick, I don't know, let's say negative 5, right? Negative 5 is less than negative 3, right? So if you pick negative 5, then under the square root, we're going to have like negative 5 plus 3, and that's negative 2, right? Negative 5 plus 3, that'll be negative 2. So we're going to have a negative 2 under the square root, and that's not allowed, right? You cannot have negative numbers under the square root. So you see why we had to exclude all the numbers, any number less than negative 3.
Professor, I have a
Yes.
question.
Yes,
So when we deal with an equation that has a square root, we like the number outside of it doesn't matter, just the numbers under the square root.
Yes, yes. We don't care about anything which is outside the square root. It doesn't matter because we have to make sure that what's under the square root is positive or 0. Anything outside, it doesn't really matter.
Okay, thank you.
So just to clarify things, guys. So here, as I said, there are two things you have to check. If there is a division, right? So when there is a division, what you have to do is we have to solve an equation, right? Like here, you know, in the first example, I had to we had division by x minus 2, and so we had to solve x minus 2 equal to 0, right? So whenever you have a division, then you're gonna have some equation to solve, okay? Something equal to 0, okay? When you have a square root, you have to solve like an equality, right? Something larger or equal to 0. Like here, I had this x plus 3, and I had to make sure that this is larger or equal to 0, so I had to solve this inequality. So the idea, guys, so if you have a division, this is like a summary or idea. So the idea is, so if you have a division, then you have to solve denominator equal to 0. Okay, so if you have a division, solve denominator equal to 0, and you have to exclude the answer from the domain. Okay, so exclude the answer or the answers from the domain. Now, if you have a square root, that's another story. So if you have a square root, you have to solve what's under the square root larger or equal to 0. Okay, so we have to solve wherever you have under the square root larger or equal to 0. Okay, and that will be your domain. And that would be, of course, you have to solve for x because the domain, it's all about x, the input x, right? That will be the domain. That will be the domain. All right, guys. So this is like a kind of summary here. I mean, you don't really need to memorize these examples. All you have to keep in mind, if you see a division, solve denominator equal to 0, and you have to exclude the answers from the domain. From the number line here, sorry. Yeah, from the domain. And if you have a square root, you have to solve whatever you have under square root larger or equal to 0, and that will be your domain. Okay.
Professor, can you?
I'm gonna give you exercise support. Yeah, please.
I have a
okay.
Yes, please.
For domains, where are they found in math, in regular math? What are the practical uses?
But because you need to know what you can input. You know, you have some function. So you have some function, then you need to know what you can input in the function f. What kind of values can x be, right? So So if you have a function, sometimes you have to exclude some numbers. You have to include some values of x. And again, the thing is because we are not allowed to divide by 0, we are not allowed to have these negative numbers and the square root. So you have to make sure that the function is well defined. So I would say the idea here is to make sure that the function is well defined, right? That's the idea. So that's the why the domain is useful. So to make sure that domain, let me write it down here for you. So domain is useful to make sure that the function is well defined. The function is well defined, because if a function is undefined, then it's useless. I think there are more questions. Yes. Is there any other question? No, I think I heard someone else. All right, no problem. All right, so here's an exercise then. Exercise. So we need to find the domain of. So this is how we find the domain when we have an equation, right? I will see later after this, after the exercise, we'll see how to find the domain when you have a graph, right? Because as we said, there are two important ways to describe functions, either using equations or graphs. So this is how we find domain using equations. And I'm gonna show you later how to find the domain of function described by a graph, right? So this is like, this exercise is similar to the problem number 4 in the homework. This is problem 4, homework 1. All right, so here's a couple of functions. So first function f of x, oops. Come on, f of x, let's say x minus 4 over 3 minus x. See, number 2, f of x is 2 minus x over x squared minus x. Number 3, f of x is square root of 4 minus x plus 1. Number 4, it's a square root of x squared plus 1 minus 1. All right, and what else? Yes, last number 5, last one. F of x is 1 over square root of 4 plus x minus 2. The minus 2 is outside the square root. All right. Okay, guys. I guess I'm gonna give you let's say 10 minutes to think about this exercise. So I can tell you guys, well, this is so finding the domain. So this is like, this is problem number 4 in the first homework, but in the test, for sure, problem number 2 would be the domain. You would need to find the domain. Okay, so this is really important notion. So we have to make sure that we understand how to find the domain. Okay. So you have, let's say 5-10 minutes, guys, to think about this. I'm here to answer your questions, of course. Yes, you're correct. Yes, you're correct. Yes. Mhm. Yes, correct, guys. Um, that's for number two, Rabiul. Um, it's not correct. Let's see. Um, yes, Lisbeth, you're correct, actually. So, Rabiul, you are incorrect. It's very good. Yeah, so yeah, be careful when you solve the the denominator, right? So this is I mean, you're gonna have like a quadratic equation, right? That this is x squared. So um, so I would say number five is kind of tricky. Well, because like number five, you have like both square root and division. So just be careful with number five, and also number four actually. Um, Lisbeth, you're saying, is that the answer for number three? I guess negative. Number three. All right. So do you? I guess you are including the four, right? Yes. Okay. Then yeah. Then it's correct. Yes. Very good. Yes. Xuana. Yeah. Very good. So again, guys, all you have to memorize is that. So whenever you wanna find the domain. If you have a division, solve the denominator equal to 0. if you have the square root, you solve whatever you have under the square root larger or equal to 0. Okay, so it's just like there are like two things to do: either solving denominator equal to 0 or solving whatever you have under the square root larger or equal to 0, or both. Like in number 5, actually, I'm gonna let me see the chat. Sophie is let me see. Sophie, it's yeah, it should be +4, not -4. Yes, it should be +4. So yes, it's +4. So just be careful with inequalities, guys, because you know, when you have like inequality with a negative number. So for example, let me just say the following. So if you have I don't know, for example, minus x for some reason, let's say you have like minus x less than I don't know, 2 or something, okay? And of course you want to solve for x, right? And you want to get rid of this negative, right? So the idea would be to, if you want to get rid of the negative, you would either multiply by -1 or you divide by -1, right? So for, let's say you divide, or you multiply by -1, okay? So to get rid of this negative. But when you divide, so this negative here goes away. But then when you divide or you multiply by a negative number, then you have to change your inequality. So this less becomes actually larger. So this is now like x larger than -2. Okay, so just be careful. So if you multiply, so if you
But
multiply,
for 3,
multiply or
wouldn't it be smaller than or less than 4?
yes, yeah, absolutely, yeah.
So I would write that.
Oh yeah. Destiny, negative infinity, positive infinity for number 4. Yes, absolutely, you're right. For number 4, yeah, Destiny, you're correct. Yeah, just so again, guys, just make sure whenever, if you multiply or you divide by negative number, you have to change your inequality, right? So if you have like here's less, then if you divide by -1, then the less becomes larger, okay? Or the other way. I mean, if you have like a larger and you divide or multiply by a negative number, then the larger becomes less, okay? So number 5, as I said, is a combination of, I mean, it's kind of tricky because you have both division and a square root, right? So and number 5 is like you have like two things or two equations to solve, right? In number 5. So let's say you have 2 more minutes. So as usual, so around 8, we'll take a break of 10 minutes. Well, hopefully I'm gonna go over the whole exercise before 8. Okay, and then after that, so the plan today is, so after the domain, well, here we try to find the domain using equations, right? Next, we're gonna try to find the domain using graphs, because the graphs, they describe also functions, and then we discuss the range of functions. Do you need more time, guys, or I guess probably I can. Number 4. Okay, I think I see like there are some different
Can
answers.
you go over
right?
all of them?
Excuse me?
Can you go over all of them?
Oh, yeah. I'm gonna, yeah, sure. All right, I see like different answers. I mean, in some sense, you can check your answer. For example, let me see. So, for example, let's say I see so many answers. Right. Rabiul, you're saying a -2 infinity. Well, if you take, well, for example, if I take negative phi would be okay, because 4 plus negative phi would be +1, and then 1 minus 2 is -1, so there'll be no problem with the -3. Lorden, you're saying, sorry, yeah, Lorden, you're saying -4, 0, and then 0, infinity, and I think, Lorden, you're correct. Lisbeth, yes, I think Lisbeth and Lorden, you're both correct, guys. Xuana, you're saying -4, 0. I think there's another interval missing, which is the 0, infinity. So, for example, if you take +1, or let's say you take not +1, but let's say you take 5, +5, then 4 plus +5 would be 9. Square root of 9, that's okay. That would be +3, and 3 minus 2 would be +1. So yeah, I think so. Lorden and Lisbeth, you have the correct answers actually. Okay, so yeah, let me now go over this whole exercise before the break. So for number 1. So for number 1, guys, as I said, so the strategy is to check if you have a division or you have a square root. So here we can see there's a division, right? So there is a division. So f of x is x minus 4 over 3 minus x. So this is obviously, it's a quotient, so there's a division here. So we have to solve. Denominator equal to 0. Okay, so because the denominator cannot be 0, right? So we have to solve. You have a division, just solve denominator equal to 0. So what's my denominator? Well, it's the 3 minus x. All right, that's the whole thing, the whole denominator. So that's 3 minus x. So we have to solve 3 minus x is equal to 0. We can just add, let's say, plus x both sides. So it's plus x both sides. Right? And so that will be equal to, so then on the left side, it's 3, and on the right side, it's plus x. So x is 3. Okay, so what I'm saying here is when x is 3, my input x is 3. You see here's my x. If my x is 3, then the denominator is going to be 0, right? Because we're going to have like 3 minus 0, 3 minus 3 in the denominator. So there'll be 0 in the denominator. So you have to exclude x equal to 3. Okay, so if you have your number line going from negative infinity to positive infinity, you have the positive 3 somewhere here. So your domain would be any real number except the positive 3. So we're gonna use, as usual, we're gonna use a parenthesis, right? To exclude, so this is to exclude the positive 3. Okay, and so the final answer, so the domain of f of x is negative infinity to positive 3. As I said, infinity, it's always excluded. We're gonna always use parentheses for the infinity. Now, for positive 3, so we're gonna go from negative infinity to from left to right, right? So from negative infinity to positive 3, positive 3 excluded, and then we're gonna start again at positive 3, not at 4, not at 3.5 or 3.1. We're gonna start again at positive 3. So here union, because we're gonna have like 2 different intervals. So then again at 3 excluded, of course, positive infinity. All right. Any questions, guys? All right. Okay. For number 2, it's 2 minus x over x squared minus x. So number 2. So we have f of x, which is 2 minus x over x squared minus x. So again, ask yourself, is there a division? Yes, we do have a division, right? We don't have a square root, so we do have a division here. You have a division, then you have to solve denominator equal to 0. Okay, you don't have to really think about it, guys. Division, solve denominator equal to 0. Square root, you solve whatever you have under the square root, larger or equal to 0. So here we solve denominator equal to 0. So what's my denominator? It's the whole thing, of course, here, so which is x squared minus x. So we have to solve so we have to solve x squared minus x equals 0. Now you have to be careful when you solve such an equation, because it's a x squared. So which means, I mean, the largest power of x here is 2, which means that we have like a quadratic equation, right? So we can use the quadratic formula, or we can use quadratic formula to solve for x, or I think the easiest way would be to, here we can actually, because there's a common factor, which is x, so we can factor out x, right? There's an x in here, and there's an x in here. So x is a common factor. So here's my x, and then parentheses, right, equal to 0. So to get this x squared, I need to multiply my x by x, right? X times x would be this x squared. This is minus here, so this is my minus, and there's x. So if you pull out this x, then you need to multiply x by 1 to get this x, right? So it's x times x minus 1 equal to 0. And as I said yesterday, guys, so we have like the product of 2 numbers equal to 0, right? So I have this x times this x minus 1 equal to 0. So if you have a product of 2 numbers equal to 0, then one of the numbers must be 0. So either the x is 0, the first number, which is, or first factor is 0, so x is 0, or the second factor, or the second number, if you prefer, so that's x minus 1 is 0. X minus 1 is 0, of course, means that x is positive 1. Okay, so we got 2 solutions here, guys, right? We got x equal to 0, and we got x equal to 1. Okay, now whenever you have the division, you have to exclude the answers, right? A division, solve denominator equal to 0, and then you exclude the, so we have to exclude the answers from the domain.
So you said
Yes.
that both answers are correct?
Yes, I mean both. We have to exclude both of them, because you see, if x is 0, You see this here, the denominator? If x is 0, 0 squared
Yes.
minus 0 would be 0. So the denominator is going to be 0 if x is 0. And if x is 1, again, it's going to be 1 squared minus 1. That will be again 0, right? So for both answers, the denominator is going to be 0. And so the function is not is undefined in that case. So we have to exclude both of them, exclude both answers, okay?
Thank you.
So then the answer, again, guys, you can use your number line if you want to, so domain of f of x is, again, I mean, if you want to use a number line, so here's my negative infinity, this is my positive infinity, I'm going to need the 0, I'm going to need the 1, and so my domain is going to be any number except the 0 and the 1. So I'm going to need like parentheses at 0 and parentheses at 1. Okay, so then domain of f of x is go from left to right, from negative infinity to 0. Both are excluded. Union, another interval. And again, you start at the same point. It's not at, you don't start at 1, you don't start at 0.5, you don't start at 0.1, you start again at 0 because it's only 0 which is and 1 are excluded, okay? So union 0, 1, and both are excluded, and then union a third interval, which is 1 to positive infinity. So we have like the union of 3 intervals here, right? Does this make sense to you guys? I mean, again, you don't have really to think about it. You have the division, solve denominator equal to 0, and exclude the answers from the domain. Use parentheses to exclude the answers. Okay, so I guess there's no question. That's good. Well, hopefully, you know what you are doing, guys. So for number 2, sorry, the number 3, that's the 4 minus x. Yes, sorry, that's a 4 minus x plus 1. So number 3. So it's f of x. Sorry, come on. Square root of 4 minus x plus 1. All right. Okay, so we have to ask ourselves like the 2 famous questions: is there division? No, there is no division here. Is there a square root? Yes, we do have a square root. Well, of course, here's my square root, right? This is my square root here. So we do have a square root. So there is a square root. So you don't have to think about it. You have to solve whatever you have under the square root, larger or equal to 0. Okay. So
I
what do we
have
have?
one question about
Please.
about the one previous. Let's
Uh-huh,
say
sure.
let's say it wasn't 0 and 1 and they weren't like close. Do you still put the other, like say it was 0 and like 5, do you still put 5?
Oh yeah, of course. Yeah.
And then you start, okay.
Yeah. Let's say you have like 0 and 5, so it will be the same thing, and instead of 1, it would be 5. You mean
Okay.
like five? You mean like 5 answers, or you mean?
No. I just meant like if it was
okay.
something other.
Okay. All right. So yeah. So here, guys, we don't have a division. That's good. Well, but the bad news is that we have a square root, right? So we solve under whatever you have under square root larger or equal to 0. So what do we have under the square root is the 4. Oops. It's the 4 minus x, right? So we don't worry about the plus 1. It's not under the square root, so it doesn't matter the plus 1. So what we need here is to solve here is 4 minus x larger or equal to 0. Okay, so how to solve such inequality? We have to solve for x, of course. Solve for x. Again, guys, this is larger or equal. So don't forget this line here. This means it can be equal. So can be equal. can be equal, and this is larger. All right. I mean, you can subtract, let's say you subtract 4, you decide to subtract 4, right? For example, actually the easiest way is just to add plus x, because you have minus x, you can add just plus x. But if you decide to subtract 4, let's subtract 4, okay, both sides. So of course, if you subtract 4, then you're gonna have negative x, larger or equal to 0 minus 4, that will be negative 4, right? Now, the thing is, this is not exactly x, this is minus x. So we need to get rid of this minus, right? There's this minus here, which is bothering us, right? This is minus here, right? So how do we get rid of the minus? Well, you can multiply by -1, or you can just divide by -1. So let's divide by -1, okay? So divide by -1, both sides, all right? So when you divide by -1, so this negative here cancel out, right? And negative over negative would be positive, right? So now on the left side, we're gonna have x. On the right side, we're gonna have 4, right? But then, this is where you have to be careful, because we divided by a negative number, then we have to change. We have to change our inequality. So this is larger or equal. So the larger or equal becomes less or equal. Okay, so this is because we multiplied by, or we divided by a negative number. So either you divide or multiply by a negative number, you have to change your inequality. So multiply by a negative number. Right? So what does it say, the inequality? Well, it says now x is, so this is now less or equal, okay? The larger or equal becomes less or equal. So my x must be less or equal to 4. So the answer, so here's my number line. I have 4 somewhere. This is negative, positive. X is less or equal, so it should be on the left side of 4. So it's right here. And 4, so my x can be equal to 4. So I'm going to include the 4. So this is, so it's included because it can be equal or equal. So it can be equal to 4. So then the domain of f of x is, so you go again from left to right. So it's negative infinity 4, negative infinity excluded, positive 4 included. Okay. If you say 4 negative infinity, that's not correct. Okay. So this is, you have to go from left to right. Yes, Lisbeth.
For example, when we have, I forgot, like to divide, right? We don't have to put parentheses. We have to put like, I forgot the name of that part. After 4.
The like the bracket.
The bracket. We
Yes.
don't have to put parentheses. We have to put the bracket when we have to divide.
No, when you divide, you have to exclude, right? When you divide, there's division denominator, so denominator equal to 0. So you have to exclude your answer, right? When you divide.
Yeah.
Here,
parentheses and then the bracket.
yes, absolutely.
And
Yeah.
not both parentheses. Why not?
Yes. You mean here?
No,
No, here because
in the
here,
bracket, because at the beginning we were supposed to put parentheses, and in that one you put parentheses and then you put bracket. Why you put different?
well, the difference is because of this. You see here, my x can be equal. Do you see this line here? It means that x can be equal. So because you know the beginning, we have to solve. You see here, well, solve under square root larger or equal. So it can be equal. It can be equal. So if it can be equal, so we include the answer, right? So so this line as I said, this means that it can be equal. So my x, it can be equal to 4. It can be equal to 4, so I include it.
Okay.
That's why.
Thank you.
Okay.
Thank you.
Sure. Is there any other question here? Yes, Lauren, absolutely. All right, guys. Is there any other question? I know it's time for the break, but I'm gonna do my best and finish the exercise before the break. Okay, well, let's finish. I think we are almost. This is number 3. Number 4. Let's do the 4 and 5 before the break, and then we can take a break for 10 minutes. All right. So let me just finish. Well, probably we should take a break. Okay, well, you know what? Let's take a break, 10 minutes, and then I will finish the exercise after the break, okay? So let's take a break of 10 minutes. So break 10 minutes. Because probably it will be too much for you guys. I know it's, so I'll be back at 8:10, okay? You can, of course, you can leave, guys. I mean, you can do whatever you want. I'll be back at 8:10. All right. See you in a little bit. Yes, actually, Rabiul, I can download the file, but I don't know. Sometimes they have a trouble. They're supposed to send me an email, and sometimes they don't. But yes, I can try. Yeah, I can try to, download the file. Yeah, that's possible actually. Yeah, that's why I have a subscription, right? Yes, sure. I will try. Sure. Okay, I'll be back at 8:10.